Hello everyone, how are you? We'll wait for more 2 minutes until we'll see some more users live, and then we can start. I can start explaining uh, how we can use this slicer settings, how we can optimize our slicer settings for 3D printing. And if you have a 3D printer, then this session is going to be very valuable for you. If you want to learn how you can get the best print quality from your 3D printer just by doing some basic slicer settings, then this is the right video for you. This is the right live stream for you. And I can see few members are already live who are watching this live stream. Okay, so Sandeep, hello Sandeep, welcome to our live stream, and it's great you joined. And I'm expecting few more users to join our live stream. And if you're watching this, please comment in the chat box. At least write your 3D printer type. If you don't have a 3D printer, you can just write 3D print. You can just write 3D print. So we'll have an idea like how many users already have 3D printer into this live stream. Okay, so the slicer, basically, if you don't know what is slicer, and if you want to learn uh, through this video, then I will explain that if you have a 3D printer, and if you don't know what is 3D printer, then 3D printer is basically a device that will help you prototype your plastic objects. So I'm talking about FDM 3D printers. And 3D printers are basically a type of manufacturing device that you can use. It's similar, the similar devices that we used to see is the CNC machining or the lathe machine or the shaper machine. In the similar manner, 3D printing is also a device, manufacturing device. But all the conventional machines that we had already used in the past, like CNC, lathe machine, and all this stuff, those are following a subtractive manufacturing methodology, whereas the 3D printer is using a very latest innovative technology, that is additive manufacturing, where the parts is being manufactured layer by layer using our 3D printer. Using different kind of materials, we can create anything. So there are multiple things associated with it, like there are different kind of printers. There are industrial printers, there are uh, consumer printers, desktop printers that we generally use. So there are different categories of printers, and some printers are used on research level. Metal 3D printing is also here, resin printing is also here, but the most commonly used 3D printers are FDM 3D printers that we generally use at our homes. It's easy to use and also affordable. So Devasis is asking that how much cost of a 3D printer. So Devasis, these days 3D printers are really affordable. Like in 10 to 15,000, you can get a very good quality 3D printers. And if you'll spend more amount, the 3D printer that I recommend at this moment of time is a printer from Bamboo Lab company. There is a printer that is known as Bamboo Lab mini 3D printers, that if you are planning to get started into the industry, that 3D printer is just a means it's just the best technology available at this moment. So basically what happens when you have a 3D printer and when you have the design, like for example, if I had created something, if I had 3D modeled something in some software like AutoCAD, SolidWorks, Fusion 360, or FreeCAD, like any softwares you had used, doesn't matter. If you had created that 3D model, and if you want to create that as a physical product, then use of 3D printer is there. And whenever you create 3D models, you can export your 3D model as different file formats, right? We can export our files as DWG files, we can export it as step files, some people are exporting as STL files. So there are multiple kind of file formats. Yes, there was. It's only 15K. It will means it get the good quality 3D printer just is getting started from 15K, and then the top price is there is no limit. So based on the suitability, I think spending around 15 to 20K is sufficient enough. There is no need to spend more than that. And if you can get some second hand 3D printers around you, then that is also a good deal. If you can get it around 3,000, 4,000, 5,000, that's also a good deal. But in that case, maybe you will be getting, you have to do some sort of DIY things to make it work. So if you don't want to get into trouble, I think 20K is the best price range that you can spend to get a 3D printer. So I was talking about like what is the use of this slicer. So basically, whenever you create a solid model inside any 3D modeling software, you can export that solid models in a STL file format, right? So STL file format, you can use that file and you can 3D print it, right? So but that is not possible because 3D printers basically move based on the inputs that we are giving to its stepper motors, right? And those stepper motors are not able to interpret information from the STL files. So in that case use of 3D printers come. So in that case use of slicer comes. So what slicer does is, like, whenever we first, we cannot send our STL file directly to 3D printer. First we had to send our STL file to a slicer software. So what slicer do is it generates G codes. So if you had studied engineering, there is a subject where for CNC machine we used to write G codes, right? By using those G codes, our tool will move. In the similar manner, it also works on the same principle in case of 3D printer. And these slicer, they automatically create G codes, the best suitable G codes based on the settings you will provide, based on the preference you will give, based on the materials you will select. And that G code you can then upload to your 3D printer, and then it will start printing. So basically it's a middleman that will help you convert the language of your 3D printer from your 3D model, right? So this is what we're going to learn today. So let me, and for the today's live stream, I had selected this Orca slicer as a slicer software. And again, I'm repeating, if you are watching this live stream, uh, please comment your 3D printer type in the chat box. If you don't have a 3D printer, you can simply write 3D printer, right? Simply write 3D printer into the chat box. And also like this video, support our video, so we can create more stuff related to 3D printing. We can share our knowledge to all of you, to all my audience, to all my connections, to all my what I will say followers. So here you can see I will start my slicer software, and in this case we are using the Orca slicer. So I will just first start it, and then you will be able to see on the screen, and then I will start showing you the magic, like what magic I used to do whenever I am slicing my models and making it ready for 3D printing to upload it into the slicer software. So here you can see the software is getting launched, and it's an Orca slicer. Again, I'm repeating. And if I'll show you the version, here you can see, if you'll go and show you the version I right now I'm using is 2.0.2. So if you are if you are interested in downloading this software, you can just go onto the internet and search for the Orca slicer, then and from there you can download this. And just let me check if you can see my complete screen. Yes, you can see my complete screen. So you can see whenever you will first launch the software, the UI will look something like this. It's very clean, simple. So there are two things available onto the top that says new project and open project. So if you have an existing project, you can definitely use this open project option. But if you're just getting started, you can start with this new project option over here. It's very simple. You don't have to do anything right at this moment. And just a second. Okay, so what I will do, I will click on new project, and here you can see by default there is a 3D printer specified into this device. So in whenever you are just getting started, if you have never used this software, so in that case what will happen, maybe you had to do some 3D printer settings, right? So and how we can do that 3D printer setting, it's very simple. uh, what you have to do is just go on to the home tab, right? Start your project. Here you can say started my project, and then onto the left side, onto the top, you will see a printer section, right? And from there, if I'll click on this option, here you can see I can select multiple kind of printers from this list. For this moment, I have this Effelson SR3D printer. Here you can see this Effelson SR3D printer, so I had selected that with a 0.4 mm nozzle. and I had confirmed that, and that's why you can see the bed of my 3D printer. So this is exactly the circular bed, and the printer that I had at this moment is a Delta 3D printer. So here you can see this is the bed. Now the moment you will do that, the next thing is the specify the material for which you want to generate your G codes, right? So the material, in most cases we use PLA filaments, because PLA filament is easy to use. PLA is also a basic material type, basic plastic material type, and it's easy to print, easy to handle, also very affordable. Means the cost for these PLA filaments are very affordable. You will get a spool of filament at around 100 thousand rupees per kg. So it's really affordable, and also varieties are available in the market. You can order color of your choice, and then you can use it. So here you can see in the filament section, if I'll open this filament section, right now I had selected all the type of filaments, but the most commonly used filament types are PLA and ABS and PETG. So these three filament types are basically used. For example, if you just want to test your idea, PLA is one of the best choices. And if you're trying to create something that you want to be practical, usable, then the ABS is the second choice, because ABS has more strength and more durability. And then if you want to use something that is like a food grade kind of thing, that is like that you want to be easy to print, easy to handle, and also that comes with a good strength, then PETG is also the choice. But again, the prices varies for different kind of materials. And for me, most of the times, 95% of the time, I use only PLA filaments, right? So you can see, so my printer is selected over here. From here I can specify the type of material that I want to use, the first thing. So here I had selected PLA filament. So based on that, this slicer has given me some sort of settings that is being supplied by the 3D printer vendor with this software, and that is already uploaded over here. But still, I am going to discuss more settings that you need to change in order to get the best results, right? So the first thing, the first section that comes is the quality, right? So if you turn off the advanced, you will be able to see very basic settings that you can customize. So if you are just a beginner, then you have to keep this turned off. So you can only customize the basic settings. For example, the first thing that will comes under the quality section is the layer height. So layer height is basically the height of a single layer whenever your 3D printer will start printing. For example, if I will take a small model for it, just for the preview, so how we can import a model into this software is whatever the models we had created, and we had exported that into STL file format, right? And now if I'll click on this icon that says as add over here, so if I'll click on this option, and then from my desktop I can find that model. Let's say I want to test out this uh, worm gear, or this worm gear, right? Let's worm gear drive, and I will click on open, and here you can see, not this one, I will delete this one. I will simply select it and delete this one. Let's say I want to use this worm gear. Yes, so here you can see this is a very simple gear that I had kept over here. And now if I will click on slice, just to give you a preview, I'm just don't worry at this moment, I will show you. So here you can see this is the model, and here you can see how the 3D printer is printing. It's printing layer by layer. So each layer has a different height, right? For example, here you can see, let's say this is the first layer 3D printer will print in order to create my gear object. So here you can see that layer height is specified here as zero point 0.2. So zero point 0.2 is actually the millimeter. So it's 1/5 of the 1 millimeter size, right? So this is the layer height of my settings that we had specified into the slicer. So 90% of the time I use this layer height only. But if you have something that you want to be more accurate, or if you want, for example, if you are printing threads on a particular thing, so in that case you have to be more accurate, then you can change these layer heights. For example, you can go for zero point 0.1, so zero point 0.1 or 0.15. So it's based on the preference that you will give. You can change this layer height. And but most of the cases I prefer to work with zero point 0.2, because zero point 0.2 works best for all of my designs. And now, since you can see that advanced option is turned off, so whatever the settings I'm explaining at this moment is for normal print settings. So if you want to go next level, then you have to turn on this option, and then you will get some more settings on this quality section also to customize. So at this moment the layer height is zero point 0.2, and I will always keep this point 2 for the first layer height also and for the other layer height also, and that you can customize. This is the first layer, that will be point 2, and then if I will show you how 3D printer is moving, and further layers are all also point 2 millimeter height. That's why you can see that there is a consistency in the layer height over here, right? Now the next thing is the seam. The seam position is basically this white thing that you can see over here. So if I'll go to the top, you can see the seam is not straight. You can see the seam is not a straight. Seam is aligned at this moment, right? It is going at a particular angle. You can see that it's aligned. And if I'll change this to the random, here you can see the result. If I'll change this to random, so you can notice there is the seam is getting random, somewhere over here, somewhere over here, somewhere over here. So that doesn't really matter, because whenever the 3D printer nozzle finish printing the first layer, then before it moves to the second layer, it has to change its height, and it also has to change its starting point, and that is what is known as the seam point. So you can see the seam, I always keep it aligned, because aligned is the by default seam position, and I don't want to play with that. So I will keep that, don't worry about that at this moment. Then the precise walls, so the precise walls are not turned on at this moment, but if you want the wall finish to be better, then what you can do, you can turn on this option, and this will help make your walls precise of your final 3D printed object. So here you can see when I turn on the precise walls, you cannot notice the difference over here, but if you 3D print it, you will be noticing the difference onto your final product, or after you finish printing, right? And then only one wall onto the top surface. So this what will do, so onto the top, like if you are using some infill, then onto the top you can use different kind of different number of walls onto the top. So that I just want to keep by default whatever the by default option is over here. Then under the quality section, these are all the settings that you had to take care of. If we'll move on to the strength section, here you can see inside the strength section the wall loops are 3. So if I'll slice the plate, you can see what is this wall loops, and you can notice when we'll slice. So you can see whenever I will zoom on to this area, you can see there are 3 walls, right? One, two yellow and one orange. So the outer wall, this is known as the wall loops. So if I'll change this to 4, let's see the result. If I'll change this to 4, and if I'll slice it again, you can notice this wall layer just got changed to 1 2 3 4, right? So this will these wall loops are basically to give the strength to your body. Like if you have something that you want to be more strength, more stronger, then you can increase the wall loops, but by default most of the times it's 3, because then if you'll increase the number of wall loops, that will also increase the print time, the material consumption, right? So if you want to be very affordable while testing your model, keep the wall loop as 3 only. But and once you are happy with the result, then you can just increase the wall loops at your final design, right? And then the top surface pattern, here you can see the top surface right now the pattern is monotonic, and this is monotonic. Here you can see the preview is also available in a small square box. So we do have multiple kind of for example, if you change this to rectilinear, here you can see the change onto the top wall, that will be changed to rectilinear. Here you can see now it's rectilinear, right? So that we can also notice if we'll go and see the okay. So this is for the top surface pattern. So the only top surfaces will change, right? Only the top surface will change. Now after that there is the top cell layers. So how many solid layers you want onto the top of your body. So here I had specified 5 layers. So if we'll take the 5 layer and the layer height we are keeping as 0.2, so that comes around total thickness of uh, 1 millimeter, right? So if you are taking 5 layers with a layer height of 0.2, so that will, so on all places where my body is you can see the top of my body, the thickness of that layer will be 1 millimeter if we are keeping 5 layers. Similar manner for the bottom layers from where the model is just getting started. For example, here I will show you. Here you can see this is my bottom layer, right? So the bottom layer is also the same thing is getting applied. Number of layers we had specified 4, but that this number you can change, right? You can change 4 5 if you want to make your model more stronger. So whatever the wall thickness you had specified, wall loops you had specified, accordingly you can specify the top and bottom wall thicknesses. For example, this is 3, 3 means if we are using a 0.4 millimeter nozzle, so that will be the wall thickness of 1.2, right? And in that case, that here we are using only one thick onto the top, whereas here we are using only 0.8 thick onto the bottom. So if we want to make it consistent, then we can change this to 6, so that will comes around 1.2 at the top, and here we'll change again to 6, that will come around 1.2 at the bottom. So now we have the consistent thickness on our complete model, right? And then this infill things will come. So what is infill, I will show you. So since we had to specify the wall loops, this means wherever there is a solid body, here you can see it's not getting completely filled. You can notice that it is not getting completely filled. There is some infill, you can see that. So right now it's 15%. So wherever the hollow object is, a hollow portion is there, it's filling by only 15%. So if we'll increase that, let's say to 30, you can notice the result. So if for the 30, if we'll slice this object, you will notice that that infill just got increased to few more dense thing. So I think 35 is the most optimum infills I used for my projects, because this is one of the more even if you'll keep your infill as 100%, and in my case I am keeping infill as 35%, both will give the same strength. I had noticed that not the same strength but almost equal, means you don't need to unnecessarily fill your body from inside just to consume more material to make it heavier, or to increase the print time. So what you can do, you can only keep 35% infill, and that will work best. And the infill pattern, most of the times I use cross hatch. So here you can see what is cross hatch. So so the one layer, here you can see the one layer is getting printed on horizontal direction, and the other layer is getting printed on vertical direction. Here you can see few layer horizontal, few layer vertical. So that is why it is called cross hatch. So that there are multiple kind of patterns that you can explore. For example, the honeycomb pattern. So honeycomb pattern is also very famous one for making the infill of your body. Here you can see the honeycomb pattern will be created uh, inside your hollow body wherever the infill is required. Here you can notice that. So that we can do. Then the infill solid pattern, and the solid pattern we can keep it rectilinear, monotonic. So we have multiple options. For example, if we had selected this archimedes kind of pattern, then you can notice, like if we'll move our thing accordingly, the our infill orientation or style will move. But whatever the by is available by default is almost have the same strength and same quality, right? Now the next thing is the support. So support is really very important. For example, here you can see in this model the things that is highlighted in blue, you can see that. So let's say my printer will start printing from the bottom, right? And it will go top like this, it will keep printing, and whenever it will come onto this layer, here you can see these are just overhang areas, like it doesn't have a support from the bed. So how printer is going to print this onto the air? Like if will print, if my nozzle will start purging material at this point, the material will start falling to the bottom, to the bed, right? So that's these are the areas where we need some sort of support created from the bottom, right? And that we can do inside the support section. If we'll turn on this option that says enable support, and now if we'll slice my model, here you can see, you can notice the different a support got created, right? So the support will also be getting printed with the same material, right? If we are using PLA, then PLA using the same material, these supports will also get printed, and whenever it reaches onto this position, it will automatically start printing above the support. Here you can see that like this. So that way what it will happen, I will get a perfect surface finish even on to these blue areas where it is highlighted. So that's why the supports are important, and there are different kind of supports. So in if you have something like this model, for this model this kind of normal support is okay. But if you have some different kind of models, then you can use the tree support also. See, oh, if I'll change this tree support, and now if I'll slice it, you will be noticing the difference. Here you can see it. So these are called tree kind of supports. So the tree supports is also very common into 3D printing. Like if you have some model that needs more complex supports, then you will see how tree supports will help you to save materials. Let me show you with a different model. I will import some different STL file just to give you an idea. Let me show you. Let me open this model. So let's say we had this pipe holder that I am printing from last couple of days, and now if I'll slice it, here you can see the support type is enabled and it's tree type support I had specified. So here you can see what kind of supports I will get. It will take few seconds to generate our G code for our 3D printer. And once it is done, you will be able to see the result over here. Here you can see. So this is a tree kind of support. So it's like a branches is being created from the bottom and it's supporting the places, all the places wherever the supports are necessary, because 3D printers nozzles cannot print in air. It needs some support onto which it can print, right? So, and if I'll show you this by, like, here you can see, if I'll show you this by layer, you can notice like how it's getting printed. So let me show you. So first it will start printing supports, and then also the some part of body, and here you can see it will increasingly keep printing the body also with all the supports intact. And then this is how it will go, like this, and it will finish the body like this. Here you can see, and the moment we are done, we can simply remove these supports. They are easily breakable from the body. Even it is getting printed with the same material, you can easily break these green supports from the body. And these are known as tree supports. And if we'll change this to normal support, and we'll show you how normal support is different from the T support. It will just take few seconds to generate the tool path, because every time if you'll make even a small change, you have to regenerate the complete tool path. And that is known as the G code files. Here you can see it's slicing. So here you can see this is the normal support. So this is taking more material because they are having some kind of more dense kind of arrangement. But in case of tree supports, it takes less material. So that's why I say T support is important. Tree support is important if you have a complex model or big model. But if you have a simple model, very simple model, then using the normal support is also very okay. Now the threshold angle, always keep it 30 degree. Now the next thing is that whenever I am creating the support, here you can see whenever I will create the support, all the supports are getting created from the build plate only, not from the build plate only. Some supports are also getting created inside the body. I will show you now how. So okay, Viper is asking what do you do about seams. The seams, I don't do anything, because in case of like okay, I will show you what we can do with the seams. Just let me finish this one. So here you can see some supports are also getting created inside the body. I will show you. Here you can see these supports are getting created inside the body. Here you can see. So maybe whatever supports you getting created inside the body, sometimes they are little tough to remove, tough to break, right? So in that case, what I suggest is, all the time whenever you're creating supports, make sure that you turn on this setting that says on build plate only. So whatever the support is getting created is being started from the build plates only. The model, the slicer is not going to suggest you any supports that is getting created inside your body. So here you can see, uh, in my case, all the supports are getting created from the build plates only the extension is getting extended up to support other parts of my body, right? Here you can see that. So this is how it works actually. So that's why this option is really very important. And then the raft interface, we keep it as default. Then we'll move on to the last section that says skirt loops. So these are all skirt loops. Here you can see that right now the skirt loops is 2. So skirt loop is basically these two lines that you can see that is away from our body, right? These two lines are just to make sure that my build plate is labeled correctly. So printing some skirt will help you save some time. That's why I always print some skirt. So I in the skirt also, in the skirt only, I can make sure that my bed is labeled correctly. And if it is not labeled correctly, I can adjust the nozzle height according to my according to the these skirt loops appearance I'm getting onto my build plates. So here you can see the skirt height right now is single layer and the skirt loop is 2. So we can change this one, like if you want to keep it 5, we can do that. And if I'll slice it again, here you can see that skirt loops will change to 5 number of lines. So accordingly we can do that, whatever the settings you will need. Here you can see that. So also we can keep these skirt layers attached to the body also. So in that case, what you have to do is, there is no option turned on at this moment because we are working in a normal mode. So if you turn on the advanced mode, then you get a cut distance. So if you'll change this to 0, here you can see, and now if you'll slice it, those skirts will be near to my body without keeping any offset values. Here you can see now it's touching the body, right? So I will turn off this advanced option, I don't want to keep it. So this is how the skirts are important. And then the brim is auto at this moment, so we can create brims, inner brims, outer brims, no brims. So it's completely, I had kept this auto because as these slicer are also getting advanced at each versions or each releases they are doing. So I don't want to play with that because whatever they had specified with few of the settings are already very fine. But still, if you want to play with some of the settings just to see what different results you are getting, simply change these settings and click on the slice plate, and you will be able to see, you will be able to notice the difference into your app preview of your slicer model, sliced model. And then there is a spiral waist case, and this is basically if you want to print, if you want to print a spiral or a waist kind of thing where you want a continuous layers, then in that case you can turn on this option. But for the solid models, these options are no useful. So these are all the basic settings that I want to discuss at into this live stream. So now if you have any question, so I can see the Viper is asking that what do you mean by seams. So I told you the seams are the areas where the layer get changes. For example, for this model, here you can see, here the seam position is this one. Here you can see the white one. So at every point, for example, let's say this object will start printing from this. So here you can see at these two white dots are seam points. For example, if my nozzle starts printing from this area, and it will go like this, then it will go on to second, third, fourth, and when it comes to this point, the nozzle will change the height. So basically the two lines are joining at this point only, and that is known as the seam point, or you can also call it the joint point. So I hope it's clear to you. So this was all the things that I want to discuss. And once you are done with creating all the settings, selecting all the basic materials, specification, and all the things, then what you can do, let me just bring it back. So all you can do, simply go onto this option and change this to export G code, right? And then you can click on this export G code, and here you can see my file is getting converted as a G code file. And if I will save this onto my desktop, that just got saved, right? That just got saved, and that file we can simply take into our this one memory card, or we can upload that to our 3D printer and we can start printing. And if I'll open that file, I will open that file that we had created, that pipe holder G code file. Here you can see, let me just turn off, close other options over here, just for your sake, just a second. There are so many things I had written. Yes, so here you can see this is the G code file that we had created, and if we scroll towards bottom, here you can see there are lines and lines of G codes written. So each G code is for single layer, right? Each G code is for single layer. So by using these layers, by using these G codes, it instruct our 3D printer nozzles print head to move along X, Y, and G direction. You can notice that X, Y, and also the material extrusion type. So by using these settings, uh, we can make our 3D printer move. So this is the language our 3D printer understand. So I hope it's clear to you, like how G codes are prepared, how you can select all the optimal settings, and how you can prepare your files, STL files for 3D printing. I hope it's clear to everyone. And if you have any question, even after we'll complete this live stream, if you have any question, just comment into the chat box, and don't forget to like my videos, whatever the live streams I'm doing, and support our channel, subscribe to my channel. So guys, thank you so much, thank you so much for coming and watching and listening to me. See you in the next live stream. Thank you.